Chemical formulas. We're going to learn how to write chemical formulas today. Chemical formulas are basically a shorthand to describe the composition of a compound. So it indicates which elements are present in the compound and the relative numbers of atoms of each element. So there is a mass ratio of elements, but in the formula we're actually concerned with the particles. How many atoms of oxygen, how many atoms of hydrogen. We use subscripts to indicate the number of atoms. And the subscript comes after the element symbol, and again, we don't use the number 1. So examples, sodium chloride, NaCl. There's no subscripts in there. That means there's 1 sodium atom and 1 chlorine atom. That's the ratio of 1 to 1. I kind of think, it's like, well, if there wasn't at least 1 sodium, I wouldn't write Na. I wouldn't write Na0. So the fact that I wrote Na means there's 1. Why do I have to write the number 1 in there? If there was more than 1, I'd put a subscript. So that's 1 to 1. Carbon dioxide, CO2. So this 2 after the oxygen means that there's 2 oxygen atoms for every 1 carbon atom. Here's the formula for sucrose, table sugar. C12H22O11. So there are 12 carbon atoms for every 22 hydrogen atoms for every 11 oxygen atoms. And that ratio is always the same. Every sugar molecule has that same ratio. Let's look at these 2 compounds. Carbon monoxide, there's my pointer. CO, that's carbon monoxide. There's 1 carbon and 1 oxygen. This gas can kill you. In fact, it almost took out my whole family once up at a cabin in Minnesota. I'll tell you the story off the recording. And CO2 is carbon dioxide. Okay, this is pretty harmless stuff. Every time we breathe out, we're breathing out carbon dioxide. There's lots of carbon dioxide in the air, and that's not hurting anybody, and the plants like it a lot. But carbon monoxide can be deadly because your body takes the carbon monoxide in preference to oxygen, and your hemoglobin binds it, and then even though you have oxygen, you suffocate. It's really a bad situation. What's the difference between those 2 things? 1 oxygen atom. Okay, details matter. 1 oxygen atom, 2 oxygen atoms, difference between non-toxic and toxic. So you may wonder, well, why do we list the carbon first and then the oxygen? The pattern is that we list the most metallic elements first. And if there isn't a metal in the compound, then you just list the one that's closest to the metals. Okay. So for sodium and chloride, sodium is a metal and chlorine is a nonmetal. So we say NaCl, not ClNa. Because this would be like baby talk. And yeah, we'd understand what you meant, but it's like that's a really weird way to say that. Over here would be N2O and not ON2. Nitrogen is closer to the metals than oxygen is. If you look on the periodic table, one way to think is kind of left to right like you'd read. The one that's on the left comes before the one that's on the right. Just kind of a general pattern. This also has, we can make analogies for this. I think of the metals as being masculine and the nonmetals as being feminine. When you address a formal invitation, perhaps to a wedding, do you write Mr. and Mrs. Joe Smith or Mrs. and Mr. Joe Smith? It's always Mr. and Mrs. Why? Because that's the way we do it, right? It's convention, Mr. and Mrs. So in the element formulas, it's the metal first and then the nonmetal. If you don't have a metal, it's the one that's closer to the metals. The metals are on the left. So nitrogen and oxygen. Nitrogen is closer to the metals than oxygen is. Then they give you this list. And it's really nice of them to give us this list. We really do not need to get hung up on that. Because for the most part, you're going to be given a name or a formula, and the order will already be given to you, so you don't have to worry about it too much. Let's do this real quick. Writing formulas. The compound containing 2 silver atoms for every sulfur. Well, silver is Ag, and it says there's 2 of them and 1 sulfur. Right? Silver goes first because it's the metal. 2 nitrogens and 1 oxygen. N2O. 2 iron atoms for every 3 oxygens. Iron 2O3.